Good day everyone. So I am Sergeant M. Carcasa, and for this video I will be tackling about infinite series. So our learning objective is that at the end of the lesson the student should be able to first define an infinite series, second evaluate the sum of an infinite series, and last determine if the sum of an infinite series converges or diverges. So now let us proceed to know and define what is infinite series. So infinite series is a series that the sum of the terms of a sequence. If a sequence has finite terms, the series would be a real number, meaning we can get the exact sum and we call it a finite series. If the sequence has an infinite number of terms, then we can get and what we can get is an infinite series. An infinite series is written in the form S sub n equals to a sub 1 plus a sub 2 and so on. But we cannot add an infinite number of terms in the same way we can add a finite number of terms. To do this, the value of an infinite series is defined in terms of the limit of partial sum. A partial sum of an infinite series is a finite sum of the form S sub k is equal to a sub 1 plus a sub 2 plus a sub 3 and so on. For each positive integer k, the sum is called the kth partial sum of the infinite series, the partial sum from a sequence S sub k. If the sequence of a partial sum converges to a real numbers S, the infinite series converges. If we can describe the convergence of a series to S, we call S the sum of the series, and we write in that form and what you can see in the last formula. So as you can see, there are three things to keep in mind. First of all, the so-called for divergence. If we have a series with a generic term an, if that generic term doesn't go to 0, then the series diverges. But be careful with that. True, even if the limit of n is 0, the series could diverge or converge. We don't know yet. We have to go some more work to figure that out. Second things to bear in mind is that harmonic series diverges. So this is an example of a thing where this generic term goes to the 0, 1 over does go to 0, but the series diverges. 1 plus 1 half plus a third and etc. goes to infinity. So that is for the second thing to remember. And last is the generic geometric series, sum of 8 times r over n. It converges when r is between -1 and 1. And in that situation, the sum is over 1 minus r, where a is the first term and r is the ratio between the terms. So we have here an example, and let us determine if this example or problem is converges or diverges. So we have here 1 over 7 plus 1 over 14 plus 1 over 21 plus 1 over 28 and so on. So the 3 that there is the infinite series. So that is the sign that this problem is an infinite series. So as you can notice, the denominator are all multiplies of 7, and so we can use that fact to write this in sigma notation. So sum from equals 1 and 1 over 7n, so their denominators are going to be 7, 14, 21 and so on. Now that 1 over 7 can get factored out, then I'm looking for 1 over 7 times the harmonic series, and of course that harmonic series diverges. So we've just got a multiple of the harmonic series, so our problem must diverge. So let us now go to finding the sum of the infinite geometric series. So in finding the infinite series here is the formula where a sub infinity equals a sub 1 over 1 minus r. So let's start in getting the sum of the term of the infinite geometric series. Example, we have here the infinite geometric series 45, 15, 5 and so on. So we will use this formula to get the answer of our infinite geometric series. So S here is the sum, and this is infinity, and a sub 1 is what we call the first term, and the r here is r ratio. So let us now solve this problem. So our a sub 1 is equals to, our first term here is 45, so our a sub 1 is 45. And then our ratio is, to get the ratios, we just need to divide 5 and 15. So 5 over 15. Since this 5 over 15 cannot be divided, then this 5 over 15 cannot be divided, but we can reduce this to the lowest term. So the lowest term of this is 1 over 3. So our ratio is 1 over 3. So let us now proceed to our formula. So our formula is S sub infinity equals a sub 1 over 1 minus r. So our a sub 1 is 45 over 1 minus our ratio is 1 over 3. So 45 over 1 minus 1/3 is 2/3. And then we just interchange this then it will become 3 over 2. So the sum of the infinity is equals to 45 over 3 and 2. Then since it is division, then we can change it to multiplication. So 45 times 3 over 2 is equals to 135 over 2. So the sum of the term of the infinite geometric series is 135 over 2. So that's it. Thank you.